Alright guys, I'm going to make this really quick supplemental video to the Tyler DeWitt videos. Try not to make this take a super long time, but I think it's going to be really super helpful if you watch the whole video. It's not required. What Tyler DeWitt talks about in his videos will be great, but if you watch this, I think it is really going to help. So here are the laws that we know at this point. We know Boyle's law that relates pressure and volume. We know Charles' law. And Charles' law relates volume and temperature. Avogadro's law, and if you notice I wrote these a little weird, you'll see why in just a second. And Gay-Lussac's. So, you already know what the combined gas law is. So guess what happens if we take these four laws and I magically put them all together. Look at this. It's like amazing. If I put them all together, we get one law, and that one law is the combined gas law. Now you might say, hey, wait a minute, Mr. Malum, when we did this in class, there was no N in it. It was just PV over T, and that's true, that's right. It's because typically when you're doing combined gas law problems, you're not changing the number of moles. But I want N to be in it for this little quick tutorial video only because it's going to help us with the ideal gas law today. So here's the deal. Between the combined gas law with your N in it and the ideal gas, that's all you need to know. You don't need to have Charles' law memorized anymore. You don't need to have Boyle's law memorized anymore, because let's say you read a problem and the problem you're reading only has pressure and volume listed. Well, then what I would do is I would just cover up the variables that I don't know. And if the only variables that are listed are pressure and volume, well, look at that. That's Boyle's law. Let's say you're reading a problem and the only variables that you're given are volume and temperature. If the only things you're given are volume and temperature, you can just simply cover up the other variables. And when you cover up the other variables and the only thing you have left, aha, that's Charles' law. So if you use the combined gas law in this format, where you just cover up whatever you don't know, that's one law. It's one expression to have down, and that's all you need to know. So for example, in this problem, well, look, it's got 12 ATM, 23 liters, and 200 Kelvin. So this is a pressure, a volume, and a temperature. So what would I cover up then? Cover up the moles, because nowhere in this problem does this talk about moles, and that is the combined gas law right there. That's the one that we were using on the last couple days of class to solve for problems. So Tyler DeWitt introduced you to this number R. And here's what I want to show you about R. R comes from something that you guys know. If I take standard conditions for any particular thing is 1 ATM, 22.4 liters, 1 mole, and 0 degrees Celsius. Keep in mind 0 degrees Celsius is 273 Kelvin. But if I take 1 ATM, this is standard temperature and pressure. At 1 ATM, 0 degrees Celsius, 1 mole is 22.4 liters. So if I take that and multiply all these together, 1 times 22.4 divided by 1 times 273, I get this number right here. And this is going to be important because Tyler DeWitt's going to put it in his video. So let's say that maybe my standard conditions, because remember we could have different pressures. Let's say that instead of that, let's say that I have 760 millimeters of mercury. That's still standard pressure. It's just a different unit. At 760 millimeters of mercury, 22.4 liters will be 1 mole and 273. If I multiply these and divide, this is the number I get for R. So all R is your P1, V1, N1, T1 multiplied and divided together at standard temperature and pressure. That's all R is. If you take the standard pressure, standard volume, standard number of moles, and the standard temperature, multiply them all together. Now in class, I use this one. If I read a problem that wants me to use the ideal gas law and it says millimeters of mercury, I just convert to ATM because I know how to do that. And if I get a problem that's in KPA, I just convert to ATM. This is the only number that I use when I'm doing problems, and you'll see it's the only number that Tyler DeWitt uses also when he's doing problems. So that's it. That's where I'm going to leave this. If you're confused about what R is, watch the Tyler DeWitt videos and it will help.